Welcome back to another professional prep video. In this video, I'm going to be discussing rates that are going to be related by in a certain way. So this is going to be a simple related rates problem. In the future, you may see harder problems. We may do harder problems on this too, so you might see it there, but for now, I'm going to kick this discussion on related rates off with a simple problem. So again, here we like teaching by examples, and that's how you learn. So let's do a simple related rates question to get started. So I'm actually going to make this not that simple. I'm going to make it a word problem, but I'm going to write it out on the screen with just the important information. So let's say we have a rectangle, and the rectangle has a length of 1 and a width of 7. And let's say that this rectangle's sides are changing. So let's say that the length is going to be decreasing. Length is going to be decreasing. And you might be wondering, why am I writing dl dt? And that's because dl dt is that rate. dl dt is how we represent that the length is changing with respect to time, of course. And let's make it by 10. And I said decreasing, so that's where the negative comes in. And let's say that the width is going to be increasing. And how would we write that? dw dt. Because it's the rate of change of the width with respect to time. And let's say that that's actually increasing by 5. I'm not going to attach any units to this problem yet, but that's the information problem. That's the information that we need. And let's say that the question is, what is the rate of change of the area? So you might be asking yourself, how do we even set this up? So let's start with this. Related rate problems usually start off with some sort of a simple equation to differentiate. So here's something we can all agree on. In order to find this equation, you got to think about what the question's asking. In this case, it's asking for the rate of change of the area. So something that we can all agree on is that area of a rectangle is defined by A equals L times W, right? Length times width. So now we're looking for the rate of change of the area, though, not the area. So in order to do that, wouldn't that just be dA dt? It would. That would be the rate of change of the area. So what I'm going to do is I'm going to differentiate both sides. On this side, I get dA dt, and on the other side, looks like we have a product rule to evaluate. So let's do it. What's the derivative? Let's start with u prime v. What's the derivative of the length? Well, it's going to be dl dt times the width times w plus, what's the derivative of the width? Well, it's just dw dt because it's changing with respect to that time, even though we don't have units, times the length, of course. So you might not believe it, but we actually have essentially just solved this, because now all that we have to do is plug in our values in order to solve this. So watch how easy it is from here. dA dt equals, and now all we're doing is plugging values in. We have all these values. We just need to plug it in correctly. So what is dl dt? It's negative 10. What is the width? 7. Right? And now, what is dw dt? It's 5. And last but not least, what is the length? Which is 1. And that's it. It's actually that simple. So that's going to be negative 70 plus 5, So negative 65, and we would usually attach units to it. Say that this was all in feet per second. Say that length and width were in feet, dl/dt and dw/dt were in feet per second. So then A would be feet squared. So, or square feet, I should say. So this would be negative 65 square feet per second, or feet squared per second. So yeah, that's obviously on the simpler side of a related rates problem, but that should kick off your little discussion about, or thought process about related rates. There are harder examples for sure, and maybe we'll walk through one in a future video, but you should always remember the steps to solving these. Find a general equation, lay out all of your information, differentiate, and plug in. And once you do that, you should have enough information in the problem in order to get your answer. And if you find yourself needing some other variable, go back in the question. Maybe you missed something, or maybe you can evaluate using some mathematical formulas. But that's all I have for you for this video. So I will see you in our next video. Please like and subscribe and email us if you have any questions. Thank you, everyone.